Hello. I think our sound is working. Great. Thanks so much for joining me this afternoon. This is actually quite the delight because at this point I mostly spend my time talking with engineers, and I've really missed being at product events. And normally when I talk about this, I call it coding without complexity. But for today, what we're really talking about is why all of you as PMs care about developer tooling, particularly pertaining to some lessons I learned while doing product work and how I think about developer tooling today and how we should think about it as product managers. So first, take a second and think. How many hours per week do you think the engineering team you're working with is spending on technical debt? Or, if you want to think about it the positive way, I would reflect on how many hours per week do you think your team is spending building the new features that you want to be delivering to customers? Do you have a number? Actually get a number in your head, because you're probably going to be horrified. Stripe released a report in 2018 saying that for all of us, our teams are spending nearly half their time on doing not the thing that we want to be delivering to customers. And the number I would have guessed would have been like, oh, like 10%, 15%, maybe 20, it's annoying, it's maintenance, we have to do it. But in fact, it's way more than this. And I think this brings up the very good question of, what is going on? How did we get to this world where we have these jobs that are to prioritize software work and to deliver value to our customers, but half of the resources we're allocating and the things we're trying to get done are more about making software than they are about delivering value? And so I want to tell you the story of a simple backend and what it's like to build one today. As a PM, I spent a lot of time with my teams thinking about how my mood and their mood impacted the work that we were able to get done. As a millennial, I think a lot of times of moods in terms of emojis. And so right now, whenever you get to talk to people, it is fun, and also there's the nerve-wracking part of, will the slides work, will the audio work, all of that. And I wanted to build a simple application to help me track this, hold myself accountable, think about how my feelings were going day to day. And this is kind of how I imagined it looking. Very simple. Pick emojis from one side, have some data about the emojis on the other side. And as a PM, probably all of you have already distilled this into a list of requirements in your head. It's super simple. You are able to post a mood, you store that mood somewhere, you can see all of the moods you've checked in with, and you can maybe see some sort of aggregate statistics about this. Similarly, if you're a developer and coming from an engineering background, you probably think of it the same way, except you think, this is a really simple backend. All I need is a persistent data store, an endpoint where I can post a check-in, a post request, an endpoint where I can get all those check-ins back, and another one where I have the statistics that I can get back. But at the end of the day, it's pretty simple. Unfortunately, this is one I actually did. When you sit down to build it as an engineer or as a PM or as anyone who's excited about building software, it's not that easy. My personal experience is you open up the AWS console or the Google Cloud console and you go, oh, there's 140 options here. Don't have time for that, I just want to get my software building. Close. Okay, I guess I'll write the backend code before I think about the infrastructure part. What would I have done for this 10 years ago? We'll just make a simple Rails scaffold. Rails has this cool new API generator thing now. Let's see if that works. Now I'm stuck thinking about my dependencies and versions. I get something work locally, it's in my repo, and then I'm right back at the thing from the beginning of, all right, what infrastructure is going to support this? Maybe I'll try Render, the cool new thing that was at TechCrunch Disrupt this year. Okay, that handles my endpoints, but I still need my persistent data storage. And so suddenly something that looks like a simple application when you're thinking of it from the perspective of a PM or as an individual developer becomes a whole bunch of stuff as you start to build it out. And this isn't unique to my side projects, for instance. The reason I really started caring about this space was it kept coming up in the workplace, and I bet at least one of these stories will resonate for one of you. In my first job, I worked on Office Mobile, and we sat between the Office organization, the Windows Phone organization, SkyDrive as it was then called, now it's OneDrive, and SharePoint. And all we were supposed to be doing was making an application to show someone all of their documents until the day that SkyDrive decided to update their APIs, and we didn't have an SLA in agreement for who would be responsible for changing the Office mobile code when they changed their APIs. Suddenly, an application that's supposed to be loading all of the documents, because of a change to the developer tool to theoretically make it easier to add the APIs, meant you can no longer see all of your documents. And so your dev tooling is technically getting better for new clients, but for old clients, you might be creating a worse user experience. After that experience, I thought, okay, I want to go somewhere that has better infrastructure, better tooling, not running into these problems. And I went to Kickstarter. And yes, there were not these internal API versioning problems, but we had a different one. On Kickstarter, timeliness was really important because projects were only live for a certain amount of time. We're using a bunch of new infrastructure technology. We had all the project data stored in Redshift. But someone had to manually move all of the data from Redshift into the staging environment, which meant that a large chunk of the time, the projects on staging weren't actually live and you couldn't test the checkout flow. So suddenly you had people making changes to a code base or PMs trying to add features to this checkout flow who weren't necessarily able to tell if it worked without spending an additional 4 hours. And so the end result of this is either a bunch of wasted engineering time or the fact that you will ship things without necessarily testing them all the way, relating in breakages for end users. Similarly then, I went to another company, Lola, a travel technology startup. And I'm sure some of you have had this. The architect came in and from day one was like, we will perfectly make our architecture such that we will never have to change it and it will scale as we grow and we're going to be a consumer scale travel company and there will be so many people using this that we have to shard everything from day one. The challenge there, of course, if you try to make all of these infrastructure decisions up front to save yourself hassle later, is a lot of the time you're wrong about what your product's going to need infrastructure-wise. And in this case, the company ended up being a B2B travel management company, probably like many of the things you all work on, and individual users weren't the right thing to have sharded the database on. And so in each of these cases, really specific developer tooling architecture choices that were meant to make it easier to build software ended up having pretty dramatic end user impact. The really depressing thing about this is the common lore in software development is that this isn't actually going to get better and that we have to keep paying the costs. In 1986, Fred Brooks wrote an essay called No Silver Bullet. And in this essay, he posited the idea that software will never be orders of magnitude easier for us to build, and we can't even dream of this unless most of the things we're doing don't make sense. And so he termed that accidental complexity. And I want to introduce this as a framework for how you can think about your developer tooling. So accidental complexity in the Fred Brooks definition is very long. He distinguishes it as all software construction involves essential tasks, the fashioning of the complex conceptual structures that compose the abstract software entity, and accidental tasks, the representation of these abstract entities in programming languages and the mapping of those onto machine languages within space and speed constraints. And so if you want to think of an example about this from when he was writing this essay, you could think of memory management and garbage collection as being something that would fall into this bucket of accidental complexity. Memory management was something we had to do because of the state of the hardware we had at the time, and garbage collection was the technology that helped us spend less time on that and more time on delivering value to users. In case the Fred Brooks explanation is too long, the Ellen explanation of this is the work that you actually want to deliver to your customer that you're excited about developers working on compared to the stuff you've just got to do because you're working on a computer and you have this infrastructure. The other thing that's happened since then, and in particular I think the thing that can give us hope, is that the other philosophy that was really predominant at the time was the first tenet of the UNIX philosophy. And this idea is that when we're building software, we should make each program we write, either function or program, or at this point, we're basically entire applications, do one thing well. And to do something new, we should build a brand new thing rather than adding new stuff to the old thing. And so the end result of this is, since 1986, we have been continuing to solve problems in software by adding one more tool that solves the process of software development as we go. And rather than thinking of it as we might for product managers and say, how do we make the entire development experience better? We just say, how can I solve this one problem about the developer experience? And layering more and more things on that have to connect to each other. So I want to point out 3 particular categories that come up with accidental complexity today and how they impact all of us and how we can think about them in our product management work. And those 3 categories are infrastructure, deployment, and APIs. The disclaimer note about this is, like Jana said in the introduction, I'm currently the co-founder at Dark. And so for the last 2.5 years, I've been primarily thinking about how can we build environments that have absolutely no accidental complexity. I don't think that's necessarily where everyone's going to get to in the next little bit. It's not as though you can immediately jump to that solution. We have a lot of early work in that space. It's more about when you're thinking about this tooling and the infrastructure your teams are using and building empathy with them, understanding where the accidental complexity that might be slowing you down is coming in. So the three again, we'll talk about infrastructure, then we'll talk about deployment, then we'll talk about APIs. Infrastructure complexity today. Right now, most of what you want to do when you're setting up a backend application, like the ones we talked about earlier when I was introducing myself, is you want to be able to receive data from some source, process that data, store that data in a data store, query it to get some subset back, and then send that data somewhere, which is a pretty concise set of things when you think about it. When you sit down to try to set up infrastructure to do that technology, you actually end up with something quite complicated. You end up with a giant set of 445 different services that you can choose between when you're thinking about what to set up. How many of you have seen this before? A couple. Okay, my favorite thing about this chart, it was released by the CNCF, the Cloud Native Foundation, and they have a note at the top that asks you if you were overwhelmed when you were looking at this chart. And I don't know very many people who would not be overwhelmed by trying to think about the 455 different technologies that they could possibly use in order to solve their problem. And so when we think about why these exist now, it's not a coincidence that this chart comes from the CNCF. It's because today, when we're writing applications, we're no longer writing applications from the Fred Brooks days of you have one computer and you're writing an application that runs on this computer and the environment is exactly the same as what you're doing. We're still writing our applications on one computer and then they're getting shipped so we can distribute them onto possibly a server rack, but more likely a virtual machine or something that's getting spun up and down for us immediately as we're doing it. And so in order to manage how we're going to run things on these abstract servers that we're talking to, we are thinking about these 455 technologies. I think this is really problematic because when you think about what your team is actually trying to do, it's not that they want to set up those 455 technologies. It's not like Kubernetes is the new cool thing, let's use Kubernetes. What they should actually be thinking about is what are the core tasks of my application that I'm trying to build? Am I trying to build something that stores data? Am I trying to build an API endpoint? Am I trying to build a background worker that responds to events? Am I trying to build a cron that runs on a schedule so I can do something, say, once a day? Or am I building some sort of internal tooling? The order you should be thinking at when you're setting up this infrastructure is more around what's the core value I'm delivering to the user and what is the objective of this program, rather than what's the cool new thing in the chart that I can add to our stack. Another way of thinking about this, similarly, one of the really cool things about Lambda, if your team has started talking about Lambda, is this is very similar. Lambdas by default spin up on an event, but you can alternatively hook them up to an API endpoint, which makes them basically respond to REST calls, or you can decide to run them like a scheduled job. And so when you start to think about the future of these infrastructure technologies, these are the things that are going to help your team be focused on what am I actually trying to deliver, rather than how can I get set up to think about the thing that I want to deliver. And so that's the question from this section I want to leave you with. When you think about adding a new feature to your existing architecture, how much of the time that the development team is estimating relates to being able to get something set up at all versus writing the new logic for that service? Similarly, another thing that is interesting, especially as many teams move to a microservices-oriented world, one of the downsides of using a technology like Lambda is you often just end up with a flat list of functions without any sense of how things connect to each other. There are ways. GitHub recently actually added a nice way to see references between chunks of things in your code base. This is how we do it in Dark. You can see how workers connect to different API endpoints. But it's important to think about how do people on our team get a sense of our overall architecture and how our services fit together. Again, you probably see, maybe not this pretty, but diagrams drawn on whiteboards every time an engineer gets hired that says, okay, like we have the file structure in the code base, but the way you should actually think about the code base is this diagram on the whiteboard. Maybe someone takes a photo of the diagram on the whiteboard. They usually don't, but that's the thing that's really important for people understanding to be able to get on-ramped and start being productive in your code base right away. Similarly, the way the architecture works ends up having like real cost ramifications. And so now there's an entire set of tools that will help you understand the infrastructure components you've set up, how they connect to each other, and what the costs of each of them are. And so another question I would ask yourself when you're thinking about your development team and the speed you're able to move at is, how are you currently keeping track of your architecture, and how are people ramping up on it? Because this is the sort of thing the developers need to know to be able to contextualize the work we're asking them to do as product managers to be successful in their careers. Next piece. Talked a little bit about infrastructure technology and how we as product managers can think about our infrastructure to work better with our development teams. Deployment complexity. So going back to the pictures we had before, deployment complexity is really about saying, this is the thing that I have on my computer that I've written as code, and now I have to get it to this abstract other environment that I need to use. And in the process, I want this to be safe, and I want it to work for my users. In the ideal world, you would write something and then you would be able to use it, where you can just say, hey, I want to have an API endpoint. It will say hello world, the de facto thing you write in a new language. I open it and it exists. The nice thing about deployment like this is for each atomic tiny change you're making, you know that something's not going to go wrong. If you're interested in this concept in particular, there's a really great article by Kent Beck in the Stripe Increment magazine that came out today about what would happen if developers could only commit working code, and if everything that you wrote that didn't work just got thrown away immediately. Highly recommend. But this isn't how deployment works for most of our teams. How many people have a deployment chart in their office that looks kind of like this? How many of you know how code gets from when a developer writes the feature, all the steps it has to go through until it hits the end user? A few. So today, it's not uncommon for teams to go through 34 steps to be able to deploy something. And so I was never a fan of this question, but people used to ask me in interviews a lot, like when you type a URL into your web browser, how does that actually end up delivering a thing? And I was like, PMs don't need to know this. This is not a useful question to me. But I do think, as PMs, we should be thinking about what's happening between when a developer writes something and when it actually gets into an environment where a user is able to use it. Because every single one of these steps is a step where something can get slowed down or a step where something can go wrong. And so when I think about this, I think all of us should be asking ourselves the question of, how does the work that we're doing actually manage to weave its way to production? And are there ways we can help that happen more quickly so we're having those tighter feedback loops with our customers? Next piece of this, obviously the GIF I showed you has to do with moving really quickly and being able to have it immediately. Of course, we don't want to have everything go to our customers immediately. And so the current best practice around this is being able to use feature flags, where you can make a change behind a feature flag and see what that's happening. And I think the key thing here, when you're talking to your development team, is the only way we used to be able to keep things safe for users was by having those different environments and saying, I have my dev environment where I write locally, I have staging where we can all see it, and then I have production where it goes to users. And we've now added this new tool where we have feature flags that say, oh, it's only going to go to this subset of users. And this subset of users can be as small as I, the developer who worked on this, our internal team, our alpha group of testers, our beta group of testers. And when you have this barrier between when a feature is shipped to production and when a feature is enabled for users, suddenly this distinction of staging and production doesn't matter as much. Production is more of the real experience where you know nothing is going to break on the hardware side, but you don't have to take on the additional risk of it going to customers immediately. And so I think we should think about our software as, how can we set this up so we have the best practices by default, rather than the best practices are something we have to go and ask our engineering teams to do and kind of say, please do this thing, it's better, then I can test it with a small set of users. I think it's better to ask, hey, let's set this up where we always have it. And so something like that could look like a world where when you have an API endpoint that's getting production traffic from real users, anytime a developer starts to edit that code, it is automatically behind a feature flag that has the same name of that endpoint, perhaps the name of the developer, or something else about the changes that are going on. Then what you can do is you can write the new logic only behind the flag, make sure you go through a set of steps that you want to do as you're deploying it, and then once you've gone through the steps with those feature flags, then turn it on for all of your users. And so there are a lot of tools that are enabling developers to do this today. One in particular, who I think actually may have sponsored the event, but that I'm a big fan of, is Launch Darkly. And so Launch Darkly allows you to manage your feature flags yourself. I think one thing in particular that's really cool about doing this is that then we as product managers can have more control over the interactions that are happening and how we're shipping things to users rather than it happening to go out in a giant deploy train. So second part of that, it's not just about how does it get to production, it's about how does it get production and how long does it take to get to users once it's in that cycle, and how can you create more fine-grained control over which users that it's going to. Third piece, API complexity. So APIs used to mostly work like they were functions back in the day, and now frequently when you're connecting to an external API, which most of us do all of the time when we're building services, it might be an API that's a different part of your company, it might be one that's truly external, but the end result ends up being that you're opening up your terminal possibly to curl, or you have a fancy client like Postman or Insomnia that you're using, and you have the API docs open, and you have to write a bunch of logic and infrastructure to go with that, so all of the callbacks and error handling and retry logic. And so it no longer becomes, oh, I want to talk to Twilio, I'm just going to say, hey, I want to talk to Twilio. It becomes, hey, I'm going to talk to Twilio, and then I'm going to write like 50 lines of logic around that to do the one thing that I want to do, like send a text message. People are starting to work in this space as well. An example of a company that I really like here is Transpose, and they're specifically focused on making it easy to play and try other APIs, and specifically making it easy to do and then query the data you get back using SQL, which I think is a tool that makes it really easy for all of us to try this stuff out. They have a few pretty cool demos specifically about how, the one I like is how you can connect your Google Calendar to your Slack status, which I think is a really nice example of putting two APIs that themselves are both pretty hard to use together in a way that's really easy and more approachable. Similarly, the other nice thing about APIs is that they can be very composable when you think about what you're able to do and the tooling that any individual developer needs on your team. At the end of the day, with almost all API calls, you're going back to like the very basics of using a REST library to use HTTP calls to talk to the external service. That doesn't mean that every single application developer needs to be doing that. You could have an internal platform team that wraps that API such that the developer can be thinking of it more like a function call, where they just think about, oh, we have this wrapper that we all use that helps us talk effectively to Twilio and already has our credentials there, or helps us talk about effectively to Slack and already has our credentials there. And you can continue to think about how can you keep moving that level of abstraction up so people can use the APIs more and more easily. So I think the question with this is, since so much of the time we need to integrate with external services, we as product managers should be thinking about how much effort it is to add a new external service for our developers. In particular, I think this really weighs in because it impacts the decisions we're making between building and buying. And when it becomes really hard to add an external service, it becomes much more likely the engineering team pushes back and says, hey, we don't really need an external service, we can just build that ourselves, because of the complexity associated with integrating with external APIs today. Last piece, I think we should think a lot about how the responsiveness of our systems and the tools we have for being able to debug can help developers as they're writing code. So if some of you have kids who have learned to code, or some of you have coded in the past, one of the things that is really common in learning languages and is really important when people start programming for the first time is them seeing what's happening right away. And so you see this in platforms like Scratch, or you see this in Lego robotics, where you want to run something and then see that it worked. We also see this today a lot with front-end development in our browser tools. So if you ever use the PM trick of opening up the dev console to change the text and show it to someone in marketing and be like, is this kind of how you want it to look? That's a good example of this. But most developer tooling today doesn't have this level of insight. Most of the time, people are either having to add a bunch of print log statements for themselves or installing and configuring a complicated debugger. And the fact that every developer is relying on that individually means we're spending a bunch of time setting up that tooling, and not everyone is having the experience of being able to debug effectively as they're writing. And that tight feedback loop is one of the things that helps you make fewer mistakes, helps you deliver to customers more reliably. And so anything you can do that supports the tooling around, okay, once we say run this API call, can we see the response easily, or be able to see easily what a variable introspects to, or being able to easily inspect a database and see a sample of what the real data looks like, is really helpful for people being able to build more quickly and actually know what's going on rather than banging their head against the wall. Similarly, this is an example of being able to see a data store query and say, okay, if I check for this device ID, can I see this data around this specific device ID? And that's the sort of thing that's really helpful when you're debugging for a specific customer who might be having an error in the software. Glitch is another great example of this if you want to play with it, and so is Replit. So the last question I'll leave you with when you're thinking about the developer experience and the experience your team is having while they're trying to help you deliver things to customers is, in your code base and with the set of tooling today, how easy is it for your team to find and debug errors? So I think all of those things are things that we can do in order to reduce the complexity we're facing as we build software. I think the world that we're leaning towards for the future is one where we do make another magnitude leap, where we remove a chunk of the accidental complexity from what we're doing. I think what that looks like is that most of our developers on application teams aren't thinking about their infrastructure at all. It happens as they write code, and they're platform teams that are able to deliver that to them. It looks like we don't think as much about our deployment environments and the idea of going from dev to staging to prod, because we can have deployless environments and instead rely heavily on feature flags that give us the control over which users are seeing things. And I think we'll have a lot more awareness of the fact that we're connecting to external services, and a lot of the work we're doing is API driven rather than just being local to our own code base. But what I want to leave you with today is the next time you get into a conversation with the engineering team you're working with, and they're saying, oh, this is going to take this long, or this thing has this much technical debt, or this thing is hard, maybe ask a few of these questions about how your infrastructure is set up, about how the deployment pipeline works, and about the risks that are happening. And hopefully you can partner with your team to help them remove some of the complexity so you can deliver better, faster, more reliable software to your customers. Thank you.